Now let's move to the control frames, the last ones. Those are here to control the transmission in the sense make sure it's working seamlessly. So basically, you send a frame, remember, you acknowledge it. So that's a control frame, that's the got it frame. But there may be some cases where you send a frame and for some reason, there is somebody else here. You send a frame to many devices and then there may be some other station there. So a few things come into play here. Every single unicast frame is acknowledged. So you'll see that frame after every single unicast frame. When you send a frame to many devices, multicast or broadcast, this one is not acknowledged. And if you think about it, it makes sense, right? Who would be acknowledging it? If you send a broadcast to everybody, and if you have to wait only one SIFS before sending the acknowledgement, well, everybody is going to reply with an acknowledgement at the same time, and that's going to be a major collision. So when the frame is not unicast, when it's broadcast or multicast, it is not acknowledged, which has the consequence that you don't know if the frame was received by everybody. Some people, maybe not, you don't know. But that's the consequence of not using unicast. So that's the acknowledgement. The other type of control frame is what we call the RTS-CTS. What happens is that when you have more than one station and they are a bit far away from each other, but both in range of the access point, what can happen is that they may be sending at the same time and they would be colliding at the access point level. That happens in large cells in particular, where the stations may be on different sides of the access point, too far away to hear each other, but still in range of the AP, and they may be sending at the same time because they believe the air is free. So to avoid that system, you can switch when that happens to an RTS-CTS system, where you repeat your frame saying, I would like to send a frame. And of course that request may not be heard by the other station, but when you do so, the other side, the access point in that case, is going to respond, and responding with a clear to send. Okay, you can send your frame. And because the other station is in range of the access point, it's going to hear that CTS. So it's going to say, didn't hear any RTS, but somebody is about to send, and the AP is saying okay for that, so I need to be quiet for a while until the transmission is complete. And when the AP is going to send the acknowledgements, the other station is going to hear that as well and will understand that the communication is complete. So you see, both acknowledgements and RTS-CTS are here to help the communication be smooth, avoid collisions that do not need to happen, and make sure that the communication went okay. They have a funny structure though, if you look at the frames, because their header is different from the ones we've seen so far, in that they don't have all these 3 MAC addresses. The acknowledgements and the clear to send only have the receiver address. They don't have the sender. And if you think about it, it's normal. You send an ACK because you received a unicast frame. So who can the sender be? Well, the one to which you send the unicast frame. That's the only solution. So there is no need to say who is sending it. It has to be that one. And because the receiver address is you know who you send that frame to, so it's obvious. And the same goes for the CTS. Who can be sending the CTS? Well, the one to whom you send the RTS, who else? So it's also so obvious that there is no need to mention that, especially for frames that, if you think about it, are not useful. They're just wasting airtime just to make sure that communication can occur, but they don't have any value in themselves. So they have to be as short as possible so that these frames that are necessary don't take too much time over what is really useful, which is data transmission.